In this lecture, we are going to study about the working and also the working principle of the full bridge inverters there. Okay, so you can see it here in this diagram that the inverter uses two pairs of a control switches. This is one pair, another this is another pair. Before in the half day, this load used to be here. Now it is between the two control switches, the pairing of two control switches here. You can see it here, S1 S2, that is having a pair with the D1 D2 and D3 D4. S1 S2 S3, sorry, S1 S2, it is like this way, S1 S2 S3 S4. The reason behind of naming is during the working principle you can understand. Okay, don't get confused. S1 S2 and S3 S4, D1 D2 and D3 D4, and they are made such a way that one pairing has to be done simultaneously. Well, if you go for this pairing, the next pairing will be like this way. So that is where has to be there. So here plus voltages will be here, that is connected here, minus here, and so you have to make such a that switch S1 and S2 are simultaneous on. That is why diagonally they are simultaneous. If S1 is on, S2 should be off, like on. S1 and S2 are on simultaneously. S3 and S4 should be on simultaneously. Okay, this will be S3 and S4 will be connected to the negative supply, whereas S1 and S2 will be connected to the positive supply. Okay, that is done through a feedback diodes. These are the feedback diodes available here. You can see here it operates under two modes here. Mode 1, 0 to T by 2. In this mode, switch S1 and S2 conduct simultaneously. That is, you can see S1 via S2, one mode it is. So whatever you are giving as the EDC, it is coming across here, across the load here. Before it used to come as EDC by 2 because the half wave it is. So whatever the voltage is in there, it will be divided here. Whatever voltage you are giving, that is the same, you are getting it here. The load voltage EDC and the load current flows from P to Q at T is equals to T by 2. That is S1 and S2 are off and S3 and S4 will be on. Now at T is equals to T by 2, S3 and S4 are turned on and this is turned on. S1 and S2 are turned on. The load, now you can see here, it is connected like this. The plus is connected S3 and this one will be connected here. Because at T is equals to T, S3 and S4 are turned on, S1 and S2 are turned on again. So it is a simultaneous between mode 1 and mode 2. So what is happening here, that due to this the negative cycle has been implemented here. So this is nothing but minus EDC by 2. Okay. Now what is happening with the operation with the RL load there? Okay. Now better we'll go with the circuit and we'll analyze it. So what is happening in the mode 1, that is the at instant T1, that is at instant T1 here, the switch S1 and S2 are made on and the point P is connected to the point Q, to the positive of the DC source EDC through S1, and Q1 is connected to the negative. Hence the whatever the output is there is been given out, E0 is equals to EDC, and the load current start increasing exponentially because of presence of the inductor here. Because it's a RL load, so inductor is present, so that inductive nature will increase the current here. The instantaneous current through S1 and S2 is equal to the instantaneous load current. So whatever you are providing here is same getting same across here. This is all about mode 1. Then coming back to the mode 2, both the switches are turned off at instant T2. Due to the inductive nature of the load, the load current does not reduce to zero instantaneously, so that it is decreasing slow by slow. Then it is the self-induced voltage across the voltage which maintains the flow of the current in the same. You can see it here. The flow of current will be maintained there. This is the supply current here. The flow of the current will be, you can see here, this is energy stored here will be same. So it is showing the load current here, and this is what the load voltage, load current, and this is load voltage there. The output voltage becomes minus EDC. Output voltage becomes minus EDC, but the load current will be thus continue to flow to the direction through the D3 and D4. Okay. Thus, in this mode, the stored energy in the load inductance is returned back to the source. So, whatever it is stored, it is again returned back to the source, means it is achieving zero here. Whatever the source has given the voltage, it has given in the form of the current back to the source. The load decreases, current again decreases and goes to zero at instant T3. What I said now. Again, it will return to till here. It is the mode 2 there. Now, what is happening? It is entering into the mode 3 there. Now, in the mode 3, the switch S3 and S4 are get turned on at instant T3 there, same. Load current voltage remains negative, minus VDC. Okay, but the direction of the load current will reverse until it reaches to the peak value. The current increases exponentially in the other direction, which is negative, and load again stores the energy. This is the thing. The mode, now this is still here, it is the mode 3. Mode 1, mode 2, mode 3. Now mode 4, switch will be off, but diodes will come into the action there. D1 here, like this, it will start to read the voltage. So that time it will start to decrease the voltage. S4, S3 and S4 are turned off at the instant T4 there. The load inductance tries to maintain the load current in the same direction by inducing positive voltage. You can see here, this voltage whatever is there is been induced by this voltage supply. This will forward bias the D1 and D2. The total energy, load energy, what is returned back to the input DC supply. The load voltage becomes E0 is equals to EDC, but the load current remains negative and decreases exponentially towards zero. So here, so till here is one cycle here. Do not observe this one, but observe this one with the mode in the terms of the current here. And T1 the load current returns to zero again for the next cycle. That is S1 is on, S1 and S2 will be on. This is about the one cycle. We can observe it here. How is the current during T1, during mode 1? What is the current in the mode 1 again? Here diode currents, different levels there, and when you are reading it, you read it with reading this whatever the points and compare this graph and study with this help of this circuit diagram. Okay. Here, now whatever the contents have been taken, I have taken it from the MD Singh and KB Khanjandani, which is of the reference test mentioned by the VTU, and other two textbooks are the additional references. Thank you.